Hello, everyone, and welcome to today's SANS webcast, Strut Your Stuff. My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is Moses Hernandez, SANS instructor. If during the webcast you have any questions for Moses, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Moses.
Thank you, Carol. And thank you for everybody that's joining today. We have a full audience and we have a packed webcast. So I'm going to just start, and we're going to start with talking about struts. And by the way, for anybody that's not realized, it is Friday the 13th. And so, as I've mentioned before, as I mentioned to a few folks before the webcast, those of you I got to hear us before the webcast, today, everything could go wrong, right? So everything that can go wrong may go wrong. It's not my fault, it's the date. And so that's always fun. And for the international folks, yes, this is an American thing. So it only goes wrong in America. So that's what I found out. Hopefully you know what this is. So I figured that if we're going to be strutting our stuff, we may want to do the Rick dance. And if you don't know what this show is, unless you're offended by foul language, it's a very funny show. So this is like Rick and Morty edition. So who am I? My name is Moses Hernandez, and I help course architect some of the stuff in the Advanced Web App Pen Testing course. I also teach a lot of the Red Team pen testing courses at SANS. I'm on the internet. I have a lot of fun on the internet. You can always follow me. I kind of sort of every once in a while maintain a blog whenever I feel like writing something kind of relevant, and that's kind of haphazard. But I promise that I'll maintain it more often, and we'll see how that goes. Now, why are we here today? Well, we're here because Java Struts has been in the news in the last few years, and I know that it's been in the news because of for certain companies, and people talk about it, and it seems like there's always a Java Struts bug that somebody has to patch. And what I wanted to talk about was what exactly this thing was, how these vulnerabilities work, and how do you build payloads for this stuff going forward. And I wanted to really kind of boil down, in essence, some of the facts of what this vulnerability is. And I just have this real penchant for people that like to poo-poo on things like Java, right? Because the fact of the matter is, I don't like Java as a language, but I think that there are some great things about Java, and those great things about Java are what make it such an interesting language to exploit and play with and things like this. So with that said, I'd like to get started. So first of all, why would someone like me, who's very much interested in red teaming, be so hyper-focused on web applications? And I know that there's a lot of folks here that may or may not have a web app pen testing background, may or may not have a red teaming background. They may or may not even understand what some of the nuances are, but we all kind of inertly understand that for many enterprises today, there's very few ways in the front door, right? There's very few ways to get into the perimeter. And so we might find ourselves having an environment where we have websites, and websites are everywhere. Web applications end up being everywhere. They now control our thermostats. They control our internet connected devices. They control our routing equipment and our firewalls. They control our network. We have web services in our desktops, right? We transact on the internet through the web. And so for many organizations, the web is the front door to their enterprise. And if you're doing kind of red team engagement, you are given some pretty limited options to get into an environment, right? And what you really want is to get in, right? What you really want is to own the target and then be able to, from that target, get further into the environment. And that's what the reality of a lot of pen testers. And we know that there is a lot of ways that bad guys try to own the environment. They try to send phishing emails, they try to get spear phishing going. But I think more and more frequently, we see that there are ways into an organization through their website. And so I kind of wanted to bring this to the forefront of the conversation, because this is a crux of why we have such a hyper focus on things like struts, on things like web application pen testing in the environment. Okay, so we understand that. Why struts? Why is this thing such a big deal? And it was funny because I talked to one of the other course architects, Adrian and Justin. They're the actual course authors for the advanced course. And they've been writing blog posts and things about these struts vulnerabilities. And even up until about a few months ago, or a few weeks ago, there was yet another struts remote code execution vulnerability. It's like if Java struts was bringing back all the remote code execution bugs that we could think of. And so I read this blog post and I said, man, you know, Java struts has been suffering these last few months. We should talk about their vulnerability. We should talk about this particular exploit and what it was, so that people understand how it works. But of course, it's another bug, right? It's one of many, right? Yet another one. So which particular bug should we talk about? So there is the famous one. And by the way, what I'm showing you on the screen is the bugs just from this year. So not even prior to 2017. So just from this year, we found the March bug, which was one of the most dangerous bugs I've seen in a long time for struts. Then there was a sister bug that showed up somewhat around the same time. And then later on this summer, there was additional bugs. There was a bug that actually allowed you to use, what the bug was is in Struts version 2, and we'll get into what Struts is here in a minute, but in Struts version 2, you could take and reuse components from Struts version 1. So they built a bridge. Think of it like a translator that allowed you to translate Struts 2 into Struts 1. And it sounds crazy because it is crazy. Nobody would actually do that. But they built a translator for this thing. And then a few weeks ago, somebody found that there was a RESTful API that had an object deserialization bug in Java. Then somebody found that, oh, by the way, if you use a different templating language, there's another injection vulnerability that also allows for remote code execution. So it looks like everywhere that you looked inside of Java struts, there was all these places for remote code execution to happen, right? And so this led me to the case that poor Java struts is getting beat up, maybe rightfully so, and the poor Java language is just getting all sorts of abuse again, right? And it doesn't seem to be happening as much to any other languages with the exception of PHP. So maybe we should explore this a little bit more. There's all these different bugs, but unfortunately, all the bugs that we're showing you are all unique snowflakes. They're all fairly different in how they work, what they do, how you exploit them, right? And so today's bugs, I'm going to show you how to use the vulnerability and build a payload and an exploit. But I do have to warn you that this particular bug and the way that you exploit it will be very different from the other bugs that are out there. So just FYI, that's just something you have to deal with. So what exactly is Java struts? What is this thing? So first of all, understand that modern software is not technically developed as much as it is assembled. And it's almost like a software assembly factory. And so Java ends up being the underlying language that everybody talks to when they're assembling their software, much like Python, much like everything else. Struts, the library, is kind of like a framework, and it does require other libraries to interoperate. So typically when you install struts inside of your application, it pulls from other libraries, it pulls from other types of systems. And this is important. The reason that this is important is because patching Java struts or applying a fix to Java struts is not just simply upgrading the Java struts file, right? It requires you to actually upgrade many other components that so it's not an upgrade struts. I wish it were. If it were, so what is this? Well, struts was I guess if you were to make this a big picture, in Java, okay, struts is no people have to show what they did in the past with the original struts, right? Is that they designed this language called OGNL. Now you're probably thinking OGNL seems to be the bane of everybody's existence because struts is always vulnerable and OGNL is always vulnerable, and et cetera, et cetera. The truth of the matter is that OGNL is very, very similar to other templating languages that you might feel are superior or that you might feel are more secure. In my opinion, they're no better or different. Anytime that you have to parse something from a user, in there lies bugs, okay, or parse unstructured data. So just because people have not unearthed or discovered new ways of injecting into different templating engines does not make one necessarily more superior than the other. OGNL is just old. It's everywhere. Very old, as a matter of fact. It's actually it's actually a language, right? And this is where you get your getter and setter functions. It does have, you can use other options, right? So another popular templating language is called FreeMarker. And all that these things do is they tell the system when to expand data. Ruby on Rails has the same thing. Ruby on Rails has something called ERB by default, right? But you can change that. You can change it to other types of language-specific templating engines. Python and Django has Jinja, right? And Django and Ruby on Rails are examples of frameworks that do similar things that Struts would do. Now, Struts 2 was a fork of Struts 1, and Struts 2 was given to the Apache project. So it is an open source project, and the original company that created Struts is actually no longer around, I think. I think they closed shop or something like that. All right. Now, who uses Struts? Well, it turns out a lot of people use Struts. And I'll be honest with you. I'll be honest with the entire group here. I wasn't sure who to put on this list because everybody uses Struts. So what I decided to do was I decided to do a job search on the internet. I actually did a Google search, and I said, give me everybody, find me Java Struts jobs, right? And so I found job postings for Java Struts. Now, I welcome anybody to try and do this, to actually find job postings for developers of Java Struts. And what you're going to find is almost every company out there uses some form of Java Struts. And it probably is found everywhere. I mean, it could be found in places you wouldn't think. Maybe it's in a HVAC control system or a biomedical pump or anywhere, right? So internet connected televisions or internet connected dolls, God forbid. But you do have that logo when you install Java that says that Java is used in over 1 billion devices. So it does make you think. Okay. Okay, so I want to discover Java Struts. I want to find it. I want to see it. I want to actually look for it. How can I do this, right? And I started thinking about this as we were doing this slide deck. I was like, Java Struts is probably everywhere. How does an engineer, a pen tester, a developer, how do they identify where Java Struts is? So my first stab at it was, I'm going to do it like a red teamer would do it. And I'm going to try to find all the identifying markers that I could find for running Java Struts. And there really are not many, right? And even the ones that exist could all be overwritten and should be overwritten, right? So for example, if I found a cookie on a website that said that your session ID was a J session ID, right? Well, this could be Java Struts. Oh my God, I think I found Java Struts. Or this could be a design pattern saying that you are running some type of Java application. It could be Java servlet page. It could be Spring, which is another popular framework. Okay, so that in and of itself is not exactly how you find Java Struts. Well, what about pathing? Can I use some kind of pathing, like a .do, a .action, a .jsp? Well, pathing can be changed. As a matter of fact, if you use search engine optimization and you look at exactly what a website that is search engine optimized asks you to do, it asks you to rewrite these things so that the extensions of the files are actually hidden. They want to make pretty URIs. So the JSP file wouldn't do it either. And then there's the Apache Coyote web server. Apache Coyote, right? Well, that would mean that the Tomcat server, which is typically what you would use to host your struts, is exposed to the internet. And I'll be honest with you, you wouldn't do this, right? An enterprise that's doing this, it's very bad practice, right? You would want to hide your Java Struts application. Well, you'd want to hide it behind something that was, how do you say, rewriting things, right? So it would appear like if Java Struts and that whole framework was running on a standard web server. So you wouldn't see Apache Tomcat. You wouldn't see Apache Coyote. You would just see Apache, or you would see Nginx, or you would see HA Proxy, or even IIS, right? Because Apache Tomcat or Struts can run on Windows. It can run on Linux. It doesn't have to be Linux. It could be Windows all the time. So you should not necessarily see this. And even if you do see Apache Tomcat, there are so many other Java applications where you deploy a WAR file that would live on Tomcat that is not a necessarily identifying marker either. This is rather frustrating, all right? Now you potentially could identify this with a stack trace, right? An error message, a Java error message. But another truth is that a Java error message does not necessarily inform you whether or not you are running an appropriate version of Struts. It might tell you that Struts is there, but you shouldn't be showing people on Java. If you show me Java error messages, or you show an attacker Java error messages, you have a lot more problems. So all these things are problematic. So what is the right way of finding Java Struts? And I've come up with two potential ways, okay? And they're not listed on the slide. Okay, that's the problem. They're not listed on the slide, but there are two potential ways that you could find struts. The first potential way that you could find struts, and I just so happen to be running a Java struts application that I can show you, is to look for the existence of the Java struts library in so much in the web pages inside the WAR files that that exist. So if you have access to the host, you can find the existence of the library, and you can find out what version of Java struts you're running. This is, in my opinion, from an internal blue team exercise, the best way to find Java struts. For the red team, you're just going to have to try exploiting a box, right? And so my opinion of the situation is that if I am running Java struts, or if I'm running any web property, I expect to see that most attackers are going to be somewhat opportunistic. And those attackers that are opportunistic are going to try to upload a Java struts attack, in this case, or some other type of attack to my web server all the time because, well, if I'm doing this the right way, they cannot tell the difference between what is and is not vulnerable, right? So the attackers have to try all sorts of things to try to figure out some markers. It is kind of a challenge if you think about it, right? I mean, there's little things here and there that you can look for, little markers, but for the most part, a well-done application doesn't have these markers. Now, let me show you exactly what libraries I'm talking about. And I'm going a little bit off script, and that's okay for this. But here is a web host that I have. We'll bring this up. And this web host has, well, it has a vulnerable version of Java in it, or struts. And the way that you deploy these things, if you've never deployed it, I highly recommend that you deploy a couple of these applications to understand how it works. You go into the Tomcat directory, of which I'm here, and you go into the web apps link, of which I'm here, and you see that I've got a sample example WAR file from the Struts2 framework. And this type of application is called Showcase. It's an example application of what you could do. It's very common that you'll see a lot of examples on the internet that show this because it is included in every Struts2 download. So that's why this is here. Now, Showcase itself, if I were to list it out, it has a ton of directories in it, right? You can see all the different directories and all the different sources and everything. So if I start looking at the, one second, let's take a look for where we can find the exact path for struts. Minus name. Actually, sorry. We could do this. There we go. Gotta go one more level deep. There we go. WebINF, classes, or lib. All right, so here are all the libraries that have come down with this Struts application. And there should be some alarming ones in here. So anybody that's been looking at any of the latest Java deserialization bugs, which we do cover in 642, will notice that the Commons collection's in here, right? And the Commons collection has been the source of all sorts of evil when it comes to Java deserialization bugs because it's a very common library. At the same time, Struts is in here, and you can see all the different Struts libraries. But so is FreeMarker, Log4j, Antler, Spring for Spring MVC, Spring Web, Tiles is in here, OGNL is in here, MyFaces is in here. So there's all sorts of these Java libraries in here. And you can see that the Struts core is in here. So this is the version of Struts that I am running, the Struts core 238. This does fall into the same bugs that were discovered in March, or that were at least officially announced in March. They were probably being exploited well before March. Also, you could see the RESTful API is in here, all the different things that you would want to test with in here, right? So this ends up becoming kind of interesting because one of the only ways to kind of find this is to either exploit it create a multi-page upload, which we'll talk about in a minute, or look for the existence of this library, all right? And unless you're on the box itself, you're not going to find the existence of this library. So all sorts of interesting stuff. Now, what exactly was this March bug? First of all, remember what I said before. Each one of these particular bugs is unique. So when I show you this bug, you can't necessarily take the exact path to exploit this bug to exploit a different bug. Not exactly, right? Because every one of them will have a different way to call. But the beautiful thing about the web is that most of the time that you're dealing with web application attacks on the server where you're abusing the languages, it ends up being a fairly simpler job than it is with running a buffer overflow in C or use after free vulnerability, because we're not dealing with memory addresses, we're not dealing with operating system protections, we're not dealing with any of this stuff. All we're dealing with is typically parsing issues and logic flaws and developer mistakes, things like this. So at a high level, at the highest level, what is this? Well, CV is 2017-5638, which is a CV number. This bug was caused by two things, really. The first thing that caused it was, I guess the main part that exposed it, was when you got to a specific section of error handling, the system didn't know how to take in that message, and then it tried to prettify it. And so because you ended up prettifying a message, it exposed that the message was an OGNL sync. We'll talk about OGNL syncs. It kind of sort of falls in the class of bugs in a way, known as server-side template injection, or SSTI. Because OGNL is a templating engine, it would fall in the class of, hey, this thing is being rendered a little bit as code instead of data, so we are actually going to be able to abuse it to execute. A little bit more complicated in this particular bug, because what we're doing is we're following the structured exception handling chain, which ends up being an OGNL sync, which ends up being how we get Java execution to go. So with that said, that's really what's happening here. OGNL, kind of a review, right? Object Graph Navigational Language. Anybody that's familiar with this concept of like getter setter patterns in any kind of object-oriented language, whether that's PowerShell or .NET or Java, will understand that, yes, I want to get something and I want to set something, show it in the view state, things like that. This is the concept behind OGNL at a high level. Is it simple? Absolutely, I'm simplifying this, right? I'm not getting into the granular details due to time constraints, really. So why do I say that this was structured error handling gone awry? Well, what the person who found the bug must have noticed is that if you uploaded a multi-part form, or did a multi-part upload, if you will, if you incorrectly set the content type to something other than this is a file and what's to follow is a file, Java would throw an error, right? You would get a stack trace. Now, inside of that stack trace, there was typically in struts, the interceptors for this would try to prettify the stack trace or prettify it to the developer so that they could actually see it and not have to worry about looking at flat text. Because if you've ever seen a stack trace in any modern interpreted language or things like Java, it's long, it's very difficult to follow unless you know exactly how to follow it. And so they tried to prettify this. Where the prettification leads to is nobody expected the file upload piece of code to ever actually do a valid error. So if you follow the logic chain all the way down, it tries to parse unstructured error messages, and it tries to prettify it using OGNL. And because you are in control of that multi-part upload, you are in fact in control of a section of memory that's being, or a section of code that's trying to be rendered as OGNL, but instead of it being system or developer supplied OGNL, it is now attacker controlled OGNL. It draws out something like, it's an OGNL sync. It's a pretty farm sync, by the way. How does this look? Like, where can I find this in the code? Well, you have to start reading Java. The nice thing is you can. The source code is available. You can go on GitHub. You can start reading exactly what they did. But it looks like this. There's actually something called the file upload interceptor.java file. And it doesn't understand what's being uploaded, so it tries to handle the error. But it can't. So it passes this unknown error to this other file, or this other function, localized text util.java, which in turn says, I don't even know how to handle this error. So I'm going to take it to a default error, default message condition. And it sends that to another Java file called textparse util.java. Textparse tries to clean up the message. And when it tries to clean up that message, this is your OGNL sync. So this is what caused the actual vulnerability to occur. Okay. And so it's all about how you approach a problem. And this is what we try to teach students inside of some of the classes, is that all these bugs are unique. All these bugs are going to be so different, right, when you find them, that it's really hard to try to teach you one thing, right? It's not SQL injection at all. It's much more complicated than that, right, as an example. So what we like to teach you is how do you approach a problem space in order to you to actually come up with something that's workable. And so I want to take the time right now to talk about one important fact before we jump into exploit writing and things like this. Finding a vulnerability like this can be spotted with a good set of eyes and understanding stack traces and reading some code. With enough time, you could find it, okay? And you can announce it. Building a payload that is workable and that can be used to exploit this becomes a different skill set, almost a different challenge. And if you want to build a multi-platform exploit to where you could find things in Windows and in Linux, this becomes potentially a challenge depending on the programming language, okay? So how do we deal with these things? How do we build these exploits, okay? Because vulnerability hunting is one thing, exploit writing, different thing altogether. So this is an example of the exploit, right? Now, when you first see this, here's what comes to your mind. What in the world is going on here? Good Lord, I can't understand it. But if you break it down into chunks, well, then it makes it a lot easier to understand exactly what's going on and how the attackers are doing their damage, okay? It's actually a beautiful bug when you look at it. It's very, very nice. Now, to understand the exploit, we do have to do a little bit of homework here. This is going to take some of you back to computer science days, and I'm actually kind of sad, okay? I just want to go back and reflect on this for 1 minute. I did a couple talks this year for SANS on the subject, and this is actually a very sad thing. Stanford has announced that they are no longer going to be teaching Java in its introductory to computer science courses, okay? Now, for some of you, you're going to rejoice. You're going to be like, oh, I hate Java. It's the worst thing in computer science ever. Security's a mess, blah, 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 blah. They're replacing it with JavaScript. Now, for those that have never heard me talk about JavaScript, JavaScript is an absolute train wreck, and we use it everywhere. So it's kind of sad that we're trading what I think is a very interesting and, okay, I don't like writing in Java, but the Java virtual machine has a lot of interesting properties. We're trading this up for JavaScript. It's kind of sad, but it is where we are today, okay? And so I think a lot of folly later, 5 years, 10 years from now, if you're thinking about this webcast, I just want to go on record as saying, JavaScript's a train wreck. Why are we doing this? It's the end. So, but I'm going to digress for a minute. Java, on the other hand, being a object-oriented language, has this concept of classes, something that JavaScript doesn't have, by the way. And classes can inherit from each other. So this is, if you've ever done .NET, you'll see this on .NET. This is a very popular object-oriented paradigm, right? Where if I have a java.lang.system, I inherit all the properties of Java Lang, I inherit all the properties of Java, and so on and so on. And class inheritance is just one of those things that you get used to seeing, right? But you have to think about that, because what I'm going to show you now has to do with class inheritance and being able to chain together classes. And it's a hack, right? But when you're hacking, well, everything's a hack, right? That's just the way it works. As long as you get your output, doesn't really matter. It doesn't have to be pretty. So why are we talking about this? Well, if I can inherit classes in Java, right, I can call back pieces of the Java software that you were not expecting me to call back. And we also have things like reflection and all sorts of other ways to do this. So what developers have decided to do is to blacklist certain classes, the dangerous ones, right? Which ones are the dangerous ones? Well, the developers are telling us which ones are the dangerous ones because they're blacklisting them. So for example, you want to restrict Java Lang get class or Java Lang class or Java Lang for name. These methods are, well, they're not good, right? Because with these methods, I could actually call back other methods or other classes that would introduce exploitation capabilities, specifically using things like reflection and some of the other APIs out there. Now, Struts did implement a set of sandboxes in order to prevent attackers from actually being able to find a bug and then leverage that bug to get exploitation, remote code execution, etc. However, there's a couple of fatal flaws that they have. And one of them was used inside of this particular exploit, and I thought it was brilliant, right? Very well done, clapping to the person who developed the exploit, because this was a great way of taking control of struts. So this, if you're curious about what are the excluded classes that Struts has, well, Struts has a Struts-DEFAULT.XML file. I don't like reading XML. Nobody likes reading XML. But if you're going to look at Java, guess what? You got to read XML. Now, this is a small output that I put together, taking out certain things of the Struts excluded classes constant, in which they will not allow these particular classes to actually be running on the system, right? And so you could see, if you want to build a process to build a backdoor, well, you can't, because Java Lang Process Builder is an excluded class. Java Lang class cannot bring back Java Lang Process Builder. Java Lang System cannot allow you to run system commands. Java Lang Runtime, Java Lang Object, right? All these things, right? But they also included specific Java Struts classes that relate to how Java Struts runs, and those particular classes would use things like reflection to call back things, as well as even overwrite this. Because Java OGNL, XWork action context, and security member access, those classes are what contain this constant. So if you have access to those constants, so you can't do that. And so all sorts of issues here, right? So you have to not be afraid of these things, right? You just got to find a way to get into the sandbox to remove access that was restricted in the sandbox in order to get execution. It's really what the attackers have to do. How do they do it? Well, let me bring it to another interesting artifact here. This is action context.java, and there's one line in this file. This is a big file, but there's one line that sets a string, okay? And it's a static final string, and it's a container string. And the container string is set to com.open Symfony export to action context container. Okay. Now, because this is a string, it's not a class and it's not a method. All right. So what the attackers will do, and I will show you this in a minute, what the attackers did is they leveraged the fact that this was a string and not a method, and not really brilliant, right? Because they didn't blacklist the use of this string, they blacklisted the use of the actual sandbox. Beautiful. So let's take this apart. What did we do, right? Well, the first part of it, the little dollar sign with the curly brace and the open so here's a dot, here's a semicolon. Okay, because I kind of gloss over it. Here's a dot. So these things become important because this is how you concatenate and set things and concatenate and things like that. So with that said, I've got the multi-form data. I'm setting my DM variable here to this, to OGNL default member access, right? And I want to make sure that my member access is set to DM. Now, even though I'm setting these variables, remember, by default member access is blacklisted, right? So I can't leverage this in any way right now. So the other thing that it sets is, okay, I want to remember that string, and the string was called container, so I can't change that, right? But I want to set the container string to a different context, and I want the context to be exactly what it was because it's a static, right? So you can't change that. However, because it's already set and it was a string, I can leverage it to call back through reflection, and so a class inheritance, you could call back other things, right? So what do we want to call back? Well, we want to get the instance of this particular class and we want to clear it. Well, what are we clearing? The get excluded package names. By the way, technically, a lot of the things here that are being cleared, the way that I ran the exploit a few times, not necessarily needed, but I think they're doing this just to get around some of the nuances between operating systems. So they're clearing this list, right? They're clearing this list here. So this entire list of objects that are no longer allowed to run is being cleared out, so that now you are free to build commands, operating system commands. So they're going to go ahead and they leverage it. And now they're starting to build their attack. And so the next thing that they do is they set DM. They're going to go ahead and set this variable, right? And they're setting command to who am I. And they're saying, okay, if I'm in Windows, make sure that I'm in Windows, right? This actually sees if I'm in Windows, then I'm going to run command.exe with whatever command I run. Who am I is not going to run in Windows, by the way. So you'd have to sit here and change your command to something other than who am I. Here's bin bash, and you can run the command here. And so now you have a multi-platform way of running your commands, because Java can run in Windows and Java can run in Linux or Unixes, right? Then this, even though this was blacklisted, this is no longer blacklisted. You could actually run this command, and of course, you can actually go ahead and process and start it, right? So this is actually how you start a process, and so your operating system command will run. Also, there's other parts here that I've omitted just for brevity, but it goes back in and it actually shows you on the screen. It actually will take the output of those commands and display them back to you, right? So now you have a real operating system command that works in both directions. It's kind of nice, right? So now let's talk about doing a demo here, because this is all fun. It's great to see it. How does it work, right? How do the attackers work? So a couple of things. Number one, you got to have a system that's got vulnerabilities to struts. This is not simple, right? How did I do this? I used GitHub, and I found an old version of struts that had, or sorry, an old version of Showcase that was available. So just make yourself sure that you have something like that available. Now, I try to make this as easy as possible for folks that have never done this before. First of all, let me show you what this actual application looks like. So you can go in here and take a peek. And Rutro, this is exactly what happens during a demo. Oh, actually, wait, I'm intercepting. I'm sorry. Sending everything through burp. So yeah, that was it. That was my follow-up, right? That was it. So here is the Struts application, right? Now, a well-run application wouldn't have powered by Struts and all that. This is a sample app. But you could see, it's got all these different options, all these different examples, all these different integrations. This is what it could do as a demo. And what we're focusing on is the upload, right? So you can do an upload, and you can upload a file, right? And so the way that it properly handles files, you can kind of just go in here, whatever you want, submit a file, right? That's what it does. Now, you can look at this inside of a proxy, right? So if you take a look at what's going on in the proxy, when actually I could just expand this, right? See if I could make this a little bit bigger for everybody. Okay, so here you have a post. Here's the host header. Here's the agent. Here's a refer field. And here's a JSession ID, which is a default thing. Here's the content type, multiform data, right? So right in here is where you could take, right here, you could actually, instead of content type, you can actually inject your payload, right? Now, if we try to replay this, let's see if we can send this into replay, to repeater. Dude, send to repeater. Technically, you should be able to do this. Now, I haven't done this in a while. I have an exploit for this, but let's see if we just can take this and see what happens. This is like stupid pet tricks. Let's see. Humor me here for a minute. This may work, may not work. Go. Nope, did not work. Either that or my box stopped responding. Yeah, technically did not work. It's just waiting. So right now, we're just waiting. If we do yeah, it's just waiting. So let's just do it on command line then. Here's our web app, right? And here is the CVE number, and we're going to go ahead and run this exploit. Now here, this is a great little exploit that has been circling the internet. I'm happy to provide everybody with their particular credit. And here's the exploit multi-part upload. And this is the exact same message that we've been looking at all day, right? We've got the multi-part data, we're looking for member access, we're setting member access, we're setting containers, context, we're doing the package classes, right? We're looking to see if this is Windows, and then we're using the process builder and serving back things, right? So the way that this exploit runs is pretty simple. You supply it a URL and a command, and it returns the command. And so pretty simple way of doing this one. So here's an example of the URL in action. And I want to run, I don't know, who am I? Let's just do the standard one. As you can see, when it sends in the command, it outputs Tomcat 7. And if you wanted to copy this out and put this into the multi-part, which you could see is kind of in here, see where the multi-part is. Yeah, it's right after this. Right after this here is where the multi-part is. So it just sticks it as a header right there, and it uploads it. And that's all it's doing. And so you could actually take the same vulnerability, run it in curl, copy it as a curl command. So if you want to take this and see it in curl, you could, right? And there you go. See, there it is in curl. Same command. And you could even go in here and say, hey, I want to go ahead and instead of doing who am I want to do a different command. Maybe I want to do instead of who am I want to do ID or whatever. You have to get to over here. It's gonna take forever to do that. Or you could use this little exploit to do that. You could do ls. You could do ls of slash, right, or ls of slash, do this, ls slash root, at permission denied, etc, pass, etc, etc, oh, it's a very bad shell, right? Or you can upload a backdoor. And if you listen to the testimony that happened by Equifax, who was one of the people impacted by this, they had web shells that were uploaded onto their server, right? So you could totally do that. Fun little trick to do. But that's what this exploit does. That's this particular one. And so if you want to play with this, I highly recommend you play with it. If you're looking for it, a lot of people end up with, I think what the bad guys typically do is they start doing internet scans of these exploits. I've seen it on the wire. And they just take this and they make this a scanner IP address, right? And they take this and they make it port 80, port 443. You know, they mutate this. They add different ports, right? You know, they say it's 80 or 443, whatever it is. And they don't necessarily do upload.action, right? They just start to spider your website. They're doing spiders and finding all the posts, right? And so they spider the website, they figure out what's available, they figure out what posts are there, and then they basically do something like this. And if the output of this ends up being, you know, Tomcat, Apache, WW user, anything, right? They will know that you are vulnerable. And so based on that, they will be able to tell you know, who you are, and what you've done. So anyway, so that concludes my my webcast. And so I hope you enjoyed it. I hope you enjoyed the fun little demo. I hope you learned something, and I hope I got swifty for everybody, right? So if you like this and you like to see exploits, how they're run, how they're built, how different languages work, how to get further into an enterprise, how to build exploits, then I'm happy to have you come and take a look at our advanced web app pen testing courses, or any of our pen testing courses for that matter. My name is Moses Hernandez. You can find me on the internet. It's a lot of fun, and thank you for coming. Carol, I don't know if we want to open it up for questions or if we want to look at the chat.
Yeah, thanks, Moses. I have sent out messages to the audience. If you do have any questions, please enter them into the questions window now. We currently don't have any, but while we give people a couple of minutes to think, I'd like to let everyone know that you can find your CPEs or CEUs for all completed webcasts by logging into your SANS portal account, navigate to your account dashboard, then click My Webcasts. You can then download your CEU on the right-hand side of the page. So, all right, I don't see anything. Moses, do you have any closing thoughts, or maybe you already shared those?
No, Carol, I mean, I shared them, but, you know, like I said, if you wanted to come and take a look at how we do this in more depth, we do have a fantastic course for you. But then again, so many of these SANS courses are pretty awesome. So.
All right, well, thank you so much, Moses, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.